me in welcoming them both.
You're welcome. Thank you guys for showing up. I'd like so this is a second version of the talk that Jim and Raditya gave, I think 2 years ago. There's been a little bit of changes, and there was some interesting development. It's a work in progress because, like VSAT, it's not as standardized as Wi-Fi, and so there's still many things to hack. And so probably every couple of years we can come up with new funny tricks. And it's actually easier. It sounds complicated and everything, and it's actually easier than hacking VSAT networks than hacking Wi-Fi or even web. And there's a disclaimer.
Yeah, next.
Yeah, this presentation's okay. This is just legalized. So it's funny because like 2 years ago when we first showed this problem with these satellite networks, there was a comment in the press, there was articles in the Wall Street Journal and the BBC, and some self-proclaimed experts say, oh, this is a hypothetical attack. You cannot do this. The hardware cost a fortune. And actually, you know, after the bubble, there were so many ISP backbone provider that went bankrupt. You could buy all this hardware for nearly nothing. Actually, a few years ago, you could even buy a small constellation of satellite for nothing. And anyway, we're going to start the talk, and I hope you enjoy it. There will be some little video later on.
Okay. Yeah, presentation title is like hacking the bird in the sky. It's not really bird, but yeah, it's a variety term for a satellite we get from the dictionary, Merriam-Webster dictionary. And a satellite, the description of satellite is like any object that revolves around a planet in circular or elliptical path, and all those masses that are part in that object or in the solar system, including the, for example, the Earth. We have the Moon, or well, actually, the Earth itself is a satellite to the Sun.
I think most everyone in the room went to school, so they probably
okay.
know that.
The term satellite, thanks to English science fiction writer who just like passed away a few months ago, Arthur C. Clarke, who firstly conceived that the possibility of artificial communication satellites like back in 1945. And for artificial satellites, the first one was launched, it's called Sputnik 1 by Russian and Soviet Union at that time, like in 1950 something, 1957. And it on the outside of Sputniks, as you can see, there are like 4 whips antennas transmitted on they were using shortwave frequencies like above and below what is today known as citizen band, like in 27 megahertz or something. And after 90-something days, gravity took over and Sputnik burned to the Earth atmosphere. And yeah, I think Sputnik, it's a good example that on just how simple the artificial satellite can be. And we also know satellites can be used for delivering an internet service. We know 3 typical setup. It's one-way multicast, one-way with terrestrial return. Usually the other part is dial-up or lease line. And 2-way satellite access for upload and download. And 2 years ago, we talked about the DVB. And it's really close with this kind of setup, very small aperture terminal. It is like 1- or 2-way terminal used in star mesh or similar like a hub, if you can imagine, like back in 5 or 6 years ago, we still use hub. That's the typical way how the networking using satellites been configured or set up. And right now we will talk about like TDMA access, and before that we will explain a little bit about the frequency band that use. As you can see, there are like very high frequency, ultra high frequency, and today satellites do not use only like Ku or C band, but also other bands to emit. And most of these bands aren't used for TV programs, radio program emitting, but also for special causes like emitting signal for military purpose, for example, like military satellites, signal for communication, we might know Inmarsat satellites, and also band used for meteorological satellites. People in Europe might know EUMETSAT. And all those satellites are two frequency bands, one used for the uplink and sending the data to the satellite, and the other one is downlink, sending data down to the Earth, plus another extra connection used for controlling the satellite itself, but it's within. And this is like typical setup on how we made a sample. It's an Indonesian Palapa C2 satellite. The typical configuration is using IP satellite access media with the time diffusion multiplex or TDM. It's all based in Internet protocol.
In Indonesia, the satellites are very popular because it's a huge archipelago. And it's really hard to pull cables all around the place. And satellite is one of the cheapest solutions to connect. Like, for example, you have 250 million people in the country, and you have like some of the biggest banks have branches everywhere. And they have to serve like many location, islands, etc. And VSAT is really, really popular over there.
Yeah, the typical use in Indonesia is for transactional and interactive application like online branches. They use like ERP.
Even the ATM. Have you been to Bali? Some of you probably been to Bali. If you go to Bali, you see every ATM has a small satellite antenna on the roof. And that's very common. It's like really widespread. Even you go in the kampung, you know, the slum, where there's people, they have this satellite, they have like kampung network.
Yeah.
What is it? Martin Crow. What's this project?
Kampung network.
Cyber kampung. Yeah, it's very, very widespread. And as you will see, it's not really secure.
And for technical specification of TDMA, this setup is using QPSK modulation with the asymmetry rate for downstream, like 1.2 to 20 megabytes, and the upstream is 128 and 256 kilobytes. It's quite small compared to today's broadband terminology.
And the latency is horrible. Typically, you get 600 millisecond, 800 millisecond or worse.
It's normal. Well, it should be okay if you use for ATM. ATM requires like, it works for 32 kilobytes, it's fine. And this one is like quite similar with the previous picture. The difference is the remote station connected with the terminal. It's using digital indoor or digital indoor unit or DIU. Sorry. And then we try to explain the attacks against the satellite system. Then first, there are like hypothetical attack, meaning that it's probably true, but or maybe it's require lots of effort to do that. No one be able to.
As long as we don't make a video, it's bullshit.
Yeah. Well, first, as we might know, the easiest way is to do denial of service, like uplink, downlink, jamming. I think Roberto made a talk about this issue two or 3 years ago, about how American military got problem in Iraq while transferring file on using the satellite communication. And due to denial of service, we can easily conduct like overpower uplink. It will like screw everything. Also, the orbital positioning attacks. In this case, you need like a central system or a TTC command, meaning that you own like geo satellite hub, and which has control to one satellite and move it to control another satellite. And it's all possible. We've been doing some analysis on like Earth station in Indonesia for certain satellite that made like 1980 something to 1990. It's possible to do like a direct commanding, ranging transporter spoofing, command reply, etc. And then we have some practical attack, meaning that everyone who has, or as a client, can first, well, at least misuse the service with or without the knowledge of the provider. Second one is knowing what's being transferred over the satellite. We were presented 2 years ago, the second part. Right now, we gonna explain the satellite piggybacking, meaning that we try to exploit satellite trust relationship on the VSAT network based on TDMA. Yeah, fun time.
It's the end of the day, so we prepare some video, so you're not going to fall asleep.
There's no sun. Yeah, the demo we conduct was done at Bandung. It's one of the nearest town in Jakarta, like 2 or 3 hours from Jakarta. It's our colleague Raditya.
It's near one of the Al-Qaeda training camp. This is Reddit, by the way. Unfortunately, could not make it to KL today. He's been detained by the police for interrogation.
Okay. First thing with this satellite piggybacking technique is we try to fool the satellite operator that we are an authorized customer, and we try to use the allocated frequency and transmitting our own data to our remote area. First, we have to do is like using selecting the target. We can use whatever satellites that covered in our area. There are several websites, like for example in this satcodx.com. It has like information on satellites, how they operate, frequency they use, allocation, clients, what kind of communication used for the clients. As you can see, the green color one is used for
the
data.
Public.
Yeah, it's all public.
Just add it to your card, and after you click checkout.
We just like selecting the area that we live and see the footprint of the satellite. And in this case, it's AsiaSat. AsiaSat 2 has a coverage, well, a little bit above to Indonesia, near to Bangkok. And also the transport stream bitrate, it's all explained in that website. Yeah, it's a satellite with the clients.
Even the satellite are not public, like spy satellite. There's a group of people that don't have a girlfriend, and then they spend their time trying to spot satellite. So what they do is you can see a shining object in the sky, they take a picture, and then they analyze the speed and direction of the satellite, and then they can guess the exact coordinate of the satellite, the orbit, etc. And it's also public. There's a website. I forgot the name of the group.
Second one, we have to prepare the equipment by pointing the antenna to the satellite. This tool is called inclinometer. It's the digital one to see how many degrees that we need. This one is the analog old version of the inclinometer, and the satellite dish. We have quite a lot. Then the modem, we have like 6 or 7 pairs. And the cables, etc. Well, we were lucky. We can get that from well, honestly, I used to set up a company that provide internet service using satellite. It went bankrupt, and we still kept the equipment. Plus, we have like several clients also providing satellite connectivity, and they sell the broken parts, and we have some friends that actually can fix it, like satellite dish, the outdoor unit, the modem, etc. Then next step is to find the free frequency. The free one, free is the other client or the legal client's frequency allocation that we will try to use.
Just a word about that. As Jim was running an ISP for the government, and you know, when you work for government, they always pay late, etc. So sometimes it was not possible to pay the uplink provider, so they had to find some generous satellites operated by China to provide
free internet,
free bandwidth for Indonesia.
Well,
that was during the crisis, by the way.
Yeah.
And it was endorsed by the government. But don't cut us on that.
Then we do trial on transmit and receive the data. We configure the modem. We do a manual test on transmit and receive. The code rate. Well, it's all on the manual of the modem. So we just follow. Well, none of us actually has a background on satellite things. We just learn it by ourselves. Yeah. Okay. And demodulation part. We receive data rate 64 kbps. Frequency use. Code rate. And I think, yeah, one of my friends actually working as a analyst on a company that runs satellite things. And after we present this second part last year on BCS, he came to me and he told me that actually there are several naughty customers that do the similar stuff like we did. So yeah, we just configure things up on our base and the remote area. We use at that time Padang on West Sumatra. All the configuration just exactly like the normal one. But what makes the difference is like we use the other people frequency allocation. And there are, well, the provider, of course, they be able to detect our action, and they try to jam our uplink or downlink.
How do they jam the?
Just send over power.
They actually do that.
Yeah, they do that. And we managed to come up with the workaround. The last part, we do the detection evasion. So imagine this is like the allocated frequency, the light green one, and the dark green is the frequency used by the user. User never use like the whole frequency allocation normally. And we have our own, the green, this antenna is ours. We try to use the satellite, and we use the other frequency allocation within the proper one, marked with the darker green, but we configure it with the two modems. And the purpose of the other modem, well, the first one is for uplink and downlink, but the other one is only to sniff the other parameters sent by the proper client. So normally, well, because no other way for the operator to detect who's abusing their connection, they usually contact the client and ask, can you turn off for like 2 or 3 minutes? That's their method to detect like
Very high tech.
well, normally like that. And after that, if the frequency is still used, then they'll be able to locate where are we.
Which one is the rogue user?
Yeah. And by monitoring the sniff the comment that there is no communication for a while, then we managed to wrote a script from using T-shell and do like automatic login to our Cisco router and turn off the modem automatically for like less than 30 seconds. So in that case, we be able to use the service whenever we want without being able to detect it by the operator. And yeah, hold a second. Yeah, the detection issue, the way they do it is like they require at least another satellites and satellite operator to detect the rogue carrier. It's quite similar to a GPS mechanism. You need like several points to actually view and know exactly where you are. Meaning that there is a satellite operator alliance cooperation involved to solve that problem, or there are specialized company that they deliver service by detecting the rogue carrier. And basically, it is hard to detect if the rogue carrier has ability to switch the frequency automatically prior detection. So, like a few years ago, we managed to present how to compromise the data link layer using Geovedi, and today we present how to play with the network layer. So, I think we still have a chance to improve our knowledge as like not as the operator but as the user to see another way what's weak in that system. Maybe you want to add something?
Yeah. Actually, I mean this is like one of the problems. Like 2 years ago, we showed it was possible to connect to the network. It was really I thought we were going to present now again, but we have a really short slot. You just had to, find a PID. To find a PID, you just set the PID to 1, and then you can sniff, all the other PIDs. And the PID is very similar to the SSID on Wi-Fi network. So you just
PID is program ID.
You just get the PID of another customer, and then after it's really hard. You have to find an IP address and then a MAC address, and then you're in. Here, this is another technology, and again, there's similar problems. Not only that, is that you have a widespread use of technology, and today it seems like knowledge is completely abstracted. You know, everyone is in this. This morning I was arguing with Marcus Random and I said, you know, you just put things in boxes, you know, but it's a bit of a problem. There's people, they are network engineers. There's this guy is just a system engineer. There's this guy is a web programmer, and this guy is a cable engineer. And people don't communicate, they don't have a global picture, and every time there's a vendor who comes to you, they will say, oh, you know, you have to buy our product, it's good, you're gonna get good performance and this and that. And actually the guy who sells you the stuff, and I've met people selling security product, their background, I mean, they had excellent CV. They closed like millions of dollars of sales. And they were selling vacuum cleaners, fridges, and things like that. And now they sell IT equipment. And I think this is a problem because you have people like selling you a product, and every time in the marketing brochure they will say it's secure. The security feature is not enabled. When they sell a satellite solution, they always say it's secure. It supports VPN security. Recently, like we do a lot of consulting for telecom operators, and our clients are pulling their hair, and they cannot even voice their concern because you know, they will lose face, you know, if they admit they've been, you know, fooled by the vendors. Like you have people that say, yeah, but you say we'll do this. Yes. It was in the proposal. Yes. It was in terms of, yes, but we're not going to do it. And it's always like that. And for the satellites, it's the same. They're going to sell you a secure satellite, but at the end, if you turn on encryption, you're going to have a drop of performance of 80%. Yeah. So what happened is, like we showed you 2 years ago, and probably we have the video from last year, you can actually sniff the traffic. And all the traffic is in clear text. And we've seen it over Wi-Fi, we've seen it over VSAT, and you see ATM transaction in clear text, credit card center in clear text, etc. And this is possible because there is this abstraction of knowledge. You know, everything is in a layer, and you have the guy who's like securing the system, there's another guy, you know, configuring the firewall, and there's the network guy who set up a switch, completely insecure, and he plugs one side of the firewall in the switch and the other side of the firewall in the same switch. And he leaves a default password like Cisco or the name of the bank or the name of the building or the name of the vendor. And this is really a problem. And when we look at all these problems with satellite, it's a bit annoying. It's like every time, you know, I talk to some friend, I have a friend now who works for Microsoft, and he goes, don't worry, you're going to find a solution to all the security problems. You guys are going to be out of a job in a couple of years. And he said that, I think it was like 14 years ago. And he predicted that I will be out of a job in 2 years. And said, don't worry, we're going to solve the security problem. And it's not going to be easy. Because most of the problem, okay, there's a lot of technical problems. You know, bit buffer overflow and all kinds of problems that are very technical. And we have to come up with technical solutions to the problem. But if you look at the root cause of the problem, most of the time the root cause is very simple. It's lack of training, lack of budget, lack of project management. People try to cut corner. Security is an afterthought. The people don't plan security. They just build a system, and after they try to make it secure just by patching holes, like you will patch the holes on the wheel of your bike. But you wouldn't be happy if you buy a bike in a store and it's already full of holes in the wheels, yeah? But yeah, so it's very difficult. And it's a bit scary because the impact, okay, the impact of these projects, it's a bit worrying. I didn't realize it. Even though I work in security, I didn't realize the impact until recently. When I Google, it was a bit of a vanity thing. I was looking up for an article, and I was Googling my name on Google. You know, how lame is that? But so I typed site colon.go.id, which I was looking for a particular reference on a government website for myself and Rexo Projo, a colleague of mine. And I was surprised because I found the name of my daughter, the full name of my daughter, on the government website, accessible, cached on Google. And I look at it and say, what is this? And then I look, and there's 36 million kids from primary school to uni online on Google. And at first I don't understand. I asked, what does DICNAS mean?
Yeah,
it was like the Ministry of Education. And we sent a complaint letter. And then I look again. And I go from the top URL, and then you can see all this, all the province, all the towns, etc. And you can select the school. And I look, and there's a download link for Excel sheet. And here, not only you get the name of the kid, you get the birth date, the birthplace, the home address, what school they go to, what class they go to. And it was really, we sent a complaint letter. There's a friend of mine, I mentioned it, and somehow, he contacted someone that responsible. But the first reaction was from probably some lower official. The reaction was, can you prove that anything wrong has happened with this data? So, it's like, you have to wait until some kid is going to get kidnapped before they're going to, take consideration. And then you're going to have to prove that the kidnapper was using the database. But again, if you look at the root cause of this problem, it's again, it's a poor understanding of security and a poor understanding of privacy, security, etc. For 6 months, this database was online indexed by Google, not only for kidnappers, even marketing people. You want to send a marketing brochure for children of certain age, then you have all the home address. But yeah, the root cause is the same as all those problems that we see for satellite networks, etc. There's people, they just want to make a sale. They don't know anything about security. They're going to sell security product. They're going to sell IT product, and at the end, it's going to be completely insecure. And it's the case for VSAT. It's the case for database, for government network, and everything. And it's very frustrating. So I was watching NIP Talk the other day, and they say, oh, beauty is a curse, but security is really a curse. Sometimes I wish I didn't know anything about security, because it doesn't seem there's a solution coming soon. Anyway, that was a bit of a rant.
Yeah.
But I think as we always show the technical problem, but we have to think a little bit more about what is the root cause of all these problems. And I think the root cause is very down to earth. It's a very simple thing.
Yeah. On the hacking side,
and stupidity is not an excuse.
Yeah, of course. Yeah, on the hacking side, what we're trying to deliver a message here is that hacking is not limited into computer, network, internet, etc. But also there are like wherever technology applied, you can also do hacking. Things that the point and
the analogy, like most of the guys in our company, they are aerospace engineers. All the guys that are older than Jim and me, they are like guys that were aerospace engineers. They used to do flight control, etc. And I don't know if any of you are aerospace engineers, but the failure rate that is tolerated in aerospace and in aeronautics, like 1 in billions, And here we have a whole industry where failure is the norm, like mediocrity and failure is the norm. And this has to change. And I think that I hope you guys, will help, and learn more about security and try to improve security around you. And we have to stop, thinking this is normal.
Okay. So, yeah, that's our presentation today.
Any questions?
What do you think of, or do you have any opinions about systems like Inmarsat's BGAN?
Yeah.
The question is, do we have an opinion about BGAN?
Yeah, of the Inmarsat BGAN.
The RBGAN.
Yeah, well, BGAN, RBGAN, it's quite different from the VSAT.
Well, actually, it is VSAT.
Technically, it is a VSAT.
It is VSAT, and the client authentication is only a 4-digit PIN, which is what?
That's to get into the terminal. I think on the account side.
And it's transmitted over clear text again? Over
Yeah.
a broadcast network. And they don't understand, again, that, satellite radio, it's broadcast, yeah? So there's nothing secret. It's like when people try to do MAC filtering on Wi-Fi, or, like hide the SSID and things like that. And like, again.
Think about a hub, what you can do in the hub network.
Yeah, I mean, it's microphone now. I mean, it's the BGAN and some of the later generation systems they seem to actually support crypto a lot better, considerably better.
On
In the marketing brochure, they support every security protocols. And most of the time, it's not going to be enabled. And if they do, they're probably going to do it wrong. But we'll be willing to take a look, at a specific, product or technology and, try to hack it.
I only have access for RBGAN client like 2 or 3 years ago, the old version. And after I play around with it, well, I'll be able to sniff another RBGAN client and do funny stuff, just like wireless.
Yeah, exactly the same. The RBGAN service is deprecated. It's being turned off at the end of this year.
Yeah, I have like a old laptop size with gray color.
Yeah.
You brought it here last time, yeah?
No, I didn't bring it.
Yeah. But yeah, I mean, I'd be very interested to see an analysis of the BGAN service and also some of the other, what is it called now? Comstar, I think, is another. There are a couple of other systems, and also the British military satellite system. It's actually they're leasing. They're going to start leasing bandwidth on it. I can't remember what that's called.
That will be interesting to look at.
And yeah, you know, and that's very hard, and that's very hardened. I'd be very interested to see if they actually enable some of the hardening actually for civilians.
How about the coverage, like including Asia, like KL, Jakarta?
We're not going to be able to travel to England after that.
It would be interesting to see, but you know, we'll talk obviously afterwards.
Okay, we'll try to take a look on it.
Any more questions?
It's too bright here. Okay, no questions. People want to go home.
Another rant.
All right, so that's about it. Thank you for coming.
Thanks again, everyone, and the organizer of the conference and the sponsors.
Thank you, Anthony, and thank you, Jim. That concludes our conference day 1. Before you leave, though, just a quick announcement about tomorrow's keynote.